Okay, welcome to the second video of the class 9 to 10 bridge course. My name is Siva, and in this video we will talk about coordinate geometry and linear equations. First we will talk about coordinate geometry and then we will go to linear equations. First about coordinate geometry. What do you mean by coordinate geometry? Let us take an example. So let us say this is an A4 sheet and I have a point A in the A4 sheet. I want to tell somebody where this point is located. I can say, hey, you know what, this is the A4 sheet and point A is inside the A4 sheet. That is wonderful. So is this point, so is this point, so is this point. All of them are in the same sheet. So where is your point? Okay, I can say, you know what, point A is in the upper half of the sheet. Okay, this point is also on the upper half. This point is also on the upper half. It doesn't make any difference. But instead, if I say you start from the lower left edge of the sheet and go a certain distance, and from there go up vertically a certain distance, and you will get to point A. That is a proper way, or that is a way using two values you can tell where to locate a certain point. And this is what coordinate geometry is all about. Let me start with an example. Okay, similar to the page, in the coordinate geometry, we can use two pairs of values, one pair of values, to locate any position or any point. For example, here, this horizontal value is usually called as a x value. This value is called as a y value. And with the help of x and y, we can locate any point in this particular plane. For example, if you take point B is nothing but x value of so and so and y value of so and so. Similarly, every point in the coordinate system can be identified using a pair of values. We call them the x value and the y value. This value, x value, is also called the x coordinate, and this value, the y value, let's say for point B, is also called the y coordinate. And they are always, the location of the point is always given in a pair like x comma y. This can be 2, for example. This can be 3, for example. So the location of point B is 2 comma 3 from this point. This point is called the origin. With respect to this point, we can identify the location of point A and point B. There has to be some point with relation to that you identify another location. For example, let us say I'm going from Bangalore to Tirupati, and I say the distance from Bangalore to Tirupati is some X kilometers. But from which point in Tirupati from which point in Bangalore is Tirupati X kilometers? There has to be a certain location in Bangalore from which the distance to other places is calculated. Similarly, in the coordinate system, there has to be a point from which the other locations are identified, and that point is called the origin. And the x coordinate and the y coordinate of the origin is 0, 0, because that is where the horizontal distance and the vertical distance is measured from. Okay, so let us take this diagram here. I've drawn a line AB. So how can I identify the location of the line? I can identify the location of the line by identifying the location of the endpoints. So A, the x value of A in this case is 2, the y value of A in this case is 2. So I will call this point as 2, 2. And similarly, the x value of B in this case is 4, and the y value is 3. So I can call this point 4, 3. So now that I've identified both the points, now I can say this line can be located on this particular diagram or on this particular system of coordinates using the location of its endpoints. This is how you can identify a line in the Cartesian system, or well, the coordinate system. It is also called the Cartesian system because it was initially developed by a French mathematician called Descartes. Well, I don't know if I'm pronouncing it right, but that's what it is. So let us say I want to identify the location of this square that I've drawn. If I identify the location of these points, I should be able to figure out the location of the square. So let us say this is like almost like 1, 1, not exactly, but this is 4, 1.5, and this is 4, 4, and this is 1, 4. So I know the 4 endpoints. Now I will be able to tell, if I draw the lines that connect these endpoints, I will be able to tell, okay, this is a square. Okay, now that you know what is a Cartesian geometry, we'll look at some of the concepts. Okay, so what I've done is I've redrawn the diagram a little bit. I've extended this line and extended this line both down and to the left side. So if you take a point here, we know that we've already talked about how to identify the location of this point. In this area, x is positive and y is positive. If you look at this, the horizontal line is like a number line. The vertical line is like a number line. It is vertical, that's all. So if I want to identify the location of a point here, I use the values of x and y, both are positive. If I take a point here, the value of x is negative because it's to the left of 0, and the value of y is positive. So x is negative, y is positive. If you take any point here, the value of x is negative. The value of y is also negative. And here, I take a point here, the value of x is negative, y is also negative. So using these 4 parts, we can identify the location of any point with respect to the point O, which is called the origin. By the way, this is called the first quadrant, this is called the second quadrant, this is the third quadrant, and this is a fourth quadrant. Okay, so this is primarily what coordinate geometry is all about. Primarily, it is used to identify location of points, lines, squares, triangles, or any shape for that matter within a 2-dimensional plane. I cannot draw a 3-dimensional cube in a coordinate geometry with 2 dimensions. Okay, so let us look at an example. Look at this question. Locate the lines below, locate the points below, actually, join them and describe the result. So we have 3 points. We need to locate them on the Cartesian axis. And then we have to join them. Let us see what happens. So the first point is 2, 2. So this is 2, this is 2. So the first point is here. Next is 3, -2. This is 3. And this is -2. So second point is here. Third is 4, 4. This is 4 and this is 4 approximately. So the third point is here. Now join them. So join A and C, join A and B, and join C and B. Describe the result. So after you have joined them, what do you get? You get a triangle. You get a triangle. So similarly, you can draw the shape of any 2-dimensional object on a Cartesian plane in this method, as long as you know the location of the vertices or the endpoints. For example, when you go to 10th standard, you will find that there are many other things that you can do. For example, you can find the length of AC. You can be able to tell, if you take any 3 points, what shape do they represent? And all of this is based on the knowledge of these 2 sets of coordinates called the Cartesian coordinate, the x-axis and the y-axis. As long as you know how to locate points on the x-axis, y-axis, you know enough to continue with your Cartesian or coordinate geometry in class 10. Okay, so now let us start with linear equations. Linear equations in two variables. That is what this chapter is about. So what does that mean? Let us say you go to a stationery, you buy 4 pens, and you buy 5 pencils. Totally, you paid 100 rupees. You paid 100 rupees. But you don't know, you forgot what was the cost of one pen and what was the cost of one pencil. But you want to express this in mathematical form. How do you do that? Let us say you declare a variable for the cost of one pen, cost of a pen, and declare a variable for the cost of a pencil. So now you bought 4 pens. 4 into x is the total cost of 4 pens because x is the cost of one pen. And 5 into y is the cost of 5 pencils because y is the cost of one pencil. If you add both those costs, you will get 100 rupees. So this is how you write a linear equation in two variables. First of all, why two variables? Because x is a variable, y is a variable. Why is it called a linear equation? Because if you take this equation and you draw a line or draw a graph, plot this equation on a graph, you will get a line. Linear means related to a line. Okay, similarly, 3x plus 9y is equal to 20 is another linear equation. The general form of a linear equation is ax plus by plus c equals 0. And here a cannot be equal to 0, b cannot be equal to 0. What if a and b are 0? This entire thing will become 0. You'll get c is equal to 0. This does not mean anything. Okay, now let us see how to solve a linear equation. Let us say I want to solve this linear equation. What do I do is I provide a value for x, an arbitrary value for x, and I try to find out the value for y. So 5 into 5, because x is equal to 5, plus 4 into y is equal to 100. If you take this here, you get 4y is equal to 25, and 75, and y is equal to 75 by 4. You can simplify it, get the value of y. So let us say I say x is equal to 10. Then what happens? This becomes 5 into 10 plus 4 into y equals 100. This is 50, so 4y will be 100 minus 50, which is 50, and y is 50 by 4. Similarly, for different values of x, I get different values of y. Similarly, I can keep on substituting. I can say, let us say x is equal to 50, then I get 5 into 50 plus 4y equals to 100. This is 250, so 4y equals to minus 150, and y is minus 150 by 4. I can keep on doing this. How many other values of x I put in, I get that many values of y. So what that means is this particular equation 5x plus 4y is equal to 100 has got infinite solutions because there are infinite values of x. For every value of x, I get a different value of y. So this is called, the solution for this is actually infinite. The solution for a linear equation in two variables is usually written in the form of x comma y. For example, if it takes x is 10 here and y was 50 by 4, I don't have time to simplify it right now. So this is what is called an ordered pair. The first value is x, the second value is y. I cannot turn it around. If I turn it around, then this will become, the first value will be x and the second value will be y. And this is how we solve linear equations of two variables. Previously, you must have studied about linear equation in one variable. For example, 2x minus 5 is equal to 0 is a linear equation in one variable. You can solve this easily. 2x is equal to 5, x is equal to 5 by 2. In the case of a linear equation in one variable, you will get only one solution. In the case of a linear equation with two variables, you get infinite solutions. Infinite solutions. Okay, so just to summarize what we have learned so far, we talked about linear equations in two variables. Why two variables? Because there are x and y, two variables. Solutions. So a linear equation in two variables can have infinite number of solutions. A linear equation in one variable has only one solution. So these are some of the key concepts of linear equations from ninth standard. They will be very useful. Well, you have to know, you have to understand this, because when you go to the 10th standard, you will be studying about linear equations with two variables. I mean, two sets of equations with two variables. With this, we have come to the end of this video. I will see you in the next video tomorrow.